Good morning, everyone. Welcome to this FSI311 session. Thank you for being here. Today, we are going to talk about how Santander has built an e-trading cloud-native platform on top of AWS. My name is Juan Enrique Gomez. I am a Senior Manager for Solutions Architects, working with the Santander team for the last 4 years. And with me on the stage today, it will be Jerome Casses. He is the CIO for Capital Markets at Santander Corporate Investment Banking, and also John Henriksson. He is the CIO for Fixed Income, also in Santander CIB. So please, Jerome.
Thank you, Juan. So thank you to give us, John and I, the opportunity to showcase one of our main initiatives in Santander around the trading platform and being supported by AWS. So before diving into the topic and more the technical stuff, just a few words about Santander. So as you may know, Santander is a Spanish bank, European bank, very present in many locations and in Europe and Americas, and a unique presence in Latin America. So more than 160 million customers, 200,000 employees, and John and I are part of the CIB capital market structure, for which there are close to 7,000 employees and 40,000 clients, mainly corporate and financial institution clients. So today, we're going to talk about an initiative that we started 4 years ago around the electronic fixed income platform. So at the time, we had, let's say, a mandate, okay, coming from the business, because everything is, as a business, rational when you're in a bank. So first, Darwin which is the name of the application, and the trading platform, is basically providing products, financial products, so rates and credit products, such as bonds and swap, to corporate clients or financial institution clients. And we are sending prices through what we call multi-dealer platform, such as Bloomberg and Tradeweb, and basically offering those products to those clients. So here you can see that technology is key for that business. Actually, technology in itself is the business. And therefore, 4 years ago, we had a mandate, okay, to obviously go for speed, for time to market, increase the time to market compared to what we have initially, to increase, I would say, the cost effectiveness, trying to go from more change the bank as opposed to spending too much on the run the bank, and obviously having a kind of a CI/CD mandate where we're going to have more and more delivery. So if we fast forward in that journey in 4 years, and John will go into more details later, we are, as of today, with the help of AWS, so we have a team of 50 developers or business technologists. We have two regions supporting the cloud in Europe and in the US. We have also pushed for an hybrid model in between in-house development and leveraging a couple of fintech on the connectivity side and on the UI side. We have obviously leveraged a lot the services from AWS, and has been proved very efficient. We have gone through the CI/CD journey to automate more than 5,000 tests before go live, and we end up having 300,000 lines of code. So now I give the floor to John. We'll dive a little bit more on that journey.
Thanks, thanks to all of you for coming. So I'm going to talk through a little bit the journey we went through. And we started, before even talking about the technical implementation, we started about thinking about what's the organization we need and what is the setup we need to do this project. We knew it was going to be a long project and very complicated. So we wanted to partner with our business. We needed the business to support us with funding and understanding through many years. And as Jerome said, we're in year 4 and we still have years to go. But also we knew it was going to be complex because it's technically complex and functionally complex. So we implemented a product-based organization where we created squads or teams based around the products. In our case, it means CDSs, bonds, swaps, and we have a product owner, typically someone from the business side, leading the priorities for each squad. And then you have this autonomous squad structure. And when we thought about how to staff the squad, we wanted to have as much autonomy as possible in the squad. That meant business analysts, DevOps, QAs, front-end, back-end, to avoid having too many interdependencies with other teams. So we created this startup environment. So you had an autonomous squad and a business owner just getting on and working with stuff. And that helped us to attract talent, retain talent, and also we created this partnership with the business that they understand what we're doing much better. We serve users in investment banking more or less all over the world. At the moment, as of today in Darwin, we have users in the UK, in Spain, US, and the short-term roadmap for next year is expand further into Hong Kong, Mexico, and Poland. So we knew from the beginning that we needed to do a global application. And we'll touch on that later and what that means. So from the very first beginning, after having the sort of organization set up ready, we started thinking a little bit about the architecture principles that we wanted to apply. So we started off saying that we thought the right high-level architecture was a microservices architecture. And one of the motivations around there was we knew we would have multiple platforms, no? CDS, bonds, swaps, with users basically all over the world. A lot of the components would be the same components, so the same business functional context across all these different platforms. But in terms of deployment and agility, what you don't want is to turn off a whole platform just to update the small components. Particularly if you have users around the world, it's very difficult to find these windows. No? So microservices architecture helps us with agility. We can easily find one piece for a particular platform, update it, restart it without affecting like the whole Darwin platform. We also thought that microservices would help us with efficiency. So we have a relatively large team. So as Jerome said, we're around 50 engineers, and most of them are still building the software. So with microservices, you can really have one portion of your team developing one functionality and another portion of the team developing another functionality. And as long as you have a very clear API, then there's no reason to step on each toes. No? So it helped us to be efficient in terms of the team structure. Most with we have are quite lightweight. So we can run them active, maybe across multiple availability zones. So that helped a lot with having a very fault-tolerant and resilient system. And performance is obviously key. So with microservices, you can scale only the microservices that need scaling, versus the monolith where you have to scale the whole thing. So that was also one of the reasons of going with this architecture. And in terms of quality and testing, as Jerome said, we spent a lot of time doing a testing framework, and I'm going to show you that later. And microservices is great for that because you have a microservices which has a very defined functional context, input contract, output contract, and you can put test cases around that. So you can be quite sure that whenever someone touches microservices, you run the test cases, and you know that the microservice complies with the contract, and it makes testing a lot easier. With this idea, with a domain-driven design, we came up with the idea thinking that we wanted this close link with the business, and often business and IT, we often talk very different languages. And domain-driven design really helps you because you take the business terminology and you bring that into the IT world. So when you think about the naming of the microservices, you name them according to the business concepts. And the same thing you do with the class names or maybe attributes names. So if you take a trader, they would understand our architecture. It's an RFQ service, and the RFQ service have classes, and here are the classes that have actually functional names. So it makes it easier to have this conversation between the business and IT. We work a lot with events. So if you think about a trading platform, basically you have events, which is typically the market updates, so price changes happening in the markets. And you have events as clients wanting to buy things, typical RFQ. So we implemented an event-driven architecture to handle that, and I'm going to go through that in a bit on how we used Elastic Cache to implement this. We decided very early on that we wanted to go cloud native. And there were many reasons we wanted to go cloud native, and we felt strongly about it. We said we don't want to look after hardware. We don't want to do the heavy lifting. We want to focus only on the delivery of code. I think that was one of the key drivers of using cloud native, so we use a lot of managed services. Another reason is we knew that this platform is going to take a long time to implement and it's going to stay with us for a long time. So we wanted to make sure that we could leverage on any new technology coming out from the cloud providers. In this case, AWS, and they innovate much faster than we can do in our team. So whenever there's new stuff, and we've seen a lot these days, whenever there's new technology or new capability introduced, for us it's very easy to incorporate that into our ecosystem. So if you take the architectural principles and the idea of domain-driven design, this is how it fits together. You end up with an architecture where you have microservices with very functional names like client API, RFQ engine, market data, etc. Each with a very isolated functional boundary. And I'm going to go into a little bit more detail now on the implementation of a specific microservices, just to go through the technology stack we use. So if you think about most microservices that we run, they're shielded by an application and load balancer, particularly if you think about the interaction with our users. The microservices are shielded by an Nginx server, so a typical server of always that provides the HTTP or HTTPS interface, goes down to our code, our implementation. So that's call it the functional implementation of the microservices. Then that microservice, it might talk with RabbitMQ. So at the moment we started with RabbitMQ, and we're looking at maybe going to Amazon MQ at the moment, but we're still on RabbitMQ. So RabbitMQ we use for anything that needs persistence and guaranteed delivery. So if you think about a trade, for example, you executed a trade, you don't want to lose the idea that you have closed that trade. So that we use RabbitMQ for that. But then we use other services for more volatile data. So they sit behind a network load balancer, and we use Elastic Cache, the Redis implementation for this. So think about price updates, for example. price updates, RFQ data coming in, any other market data that we need. It goes through Redis. We get very good performance. If you lose a market data update, I mean, it's not ideal, but it's not at the end of the world. So we use it really for the fast and volatile stuff. And then we have another NGX reverse proxy. If you've been working with microservices, you know that's a typical pattern to protect a little bit and allows you to do a little bit of more clever routing and throttling, etc. And then we have an OpenSearch cluster then for all the logging to get information then about the performance and the behavior of the system. So we go now to the implementation of the microservice. Now we're looking a little bit broader. How does these microservices fit together in a more wider architecture? So the front end, we've got two types of front ends. Basically, we're using OpenFin. So OpenFin is a fintech, and they provide a desktop application, which is basically a secure browser. I think you'll think of it as a Google Chrome, but it gives the experience to the user that it feels and looks like a thick client. So they have that experience, but it works like a normal web application. And then we have an Excel plugin. I mean, you can't get traders away from Excel completely. So we do provide some information to Excel for traders to use. These two, call it user front ends, they connect back to our microservices through what I said before, the application load balancer. If they're starting up for the first time, they load like the static data from S3. Think about the images and widgets, etc. for the front end. If the user is not authenticated and needs to authenticate, we're using Amazon Cognito for this. They get authenticated. And then the microservice needs to do something. It needs to either send an order because it's closed an order, goes out through RabbitMQ. If we need to write something to a database or read something from a database, I think about user preferences, for example, is a good example about the layout of the screen and the colors or trades themselves. We write and read from DynamoDB, so that's our persistent storage. If we need to connect back through like a corporate network, think of we have some systems like MiFID II compliance that sits on-prem. It goes through Transit Gateway and all the way into our corporate network. And then we use Private Link for our connectivity through to the markets. So we use another fintech called Transfic. So Transfic provides us the normalized connectivity to the marketplaces, and they give us that service through Private Link. So in our account, we have a clearly defined API. We connect to that, and from there, we go to the markets. And of course, we use Elastic Cache for all the fast information. So this is the high-level architecture. And then where you see like the microservices in the middle, think about that multiply by 10, 20, because we run a lot of different microservices. And I think this point is very important. And when we started the project, thinking about the idea that we needed a global platform, we needed that global platform to support multiple products and users all over the world, you quickly end up in your head with an image of many hundreds of microservices running everywhere with very short windows of maintenance to do updates. And you can't do that manually. You have to automate. So we invested a lot of time in automating everything. So first of all, we started with a testing framework. So you have the typical testing pyramid where we automate like the unit testing, the services, and the user interface. And we are quite strict in making sure that any new functionality we develop has the full coverage of the testing framework. But it's not enough there because you also need to automate the deployment. So with automating the deployment with very large infrastructure in the cloud, you do by code, obviously. We started using the CDK. So the CDK, it allows you to basically generate CloudFormation, but from the language of your choice. So if you're a Java developer or a .NET developer, you don't have to learn CloudFormation. You implement that in the language you're used to. So developers typically love it. We do have quite a lot of code in CDK. I think all the microservices and all the network connectivity and all the private links, they're all modeled in code. So I think we generate probably a few thousand lines of CloudFormation from CDK. Then the build pipeline, what it does is it goes through the CDK, generates all the CloudFormation. CloudFormation deploys our environment. So that sets up the whole environment, so we can spin up a whole new Darwin environment in a question of minutes. And then the first thing we do is we run all the tests. So we test that everything's working fine. And from that on, you go to production, and even in production, we've automated everything. So like when you're running hundreds of microservices in production, you can't have anyone going inside and touching stuff. And actually, what happens with managed services is you can't anymore, because a lot of the controls, like you don't log into a machine with a root user and do stuff. The management tasks are typically provided by APIs. So you end up also automating all the management tasks, and you drive them from your CI/CD pipelines. So that makes it very easy for us to release frequently. I think that's one of the key things. Jerome is going to touch on that later when it comes to the business benefits, but we've seen a drastic improvement in how often we release to production now. The group landing zone, Juan Enrique is going to talk about that, is using Terraform. So we have a bit of a mix, like the Terraform automations in the landing zone. They do provision the basic infrastructure for us, the security controls, the VPC setup, etc. And then the more specific application configuration in the pipelines is done by CDK. Just very, very briefly here, I'm not going to go into a lot of detail, but this is what the user interface looks like. It's the OpenFin navigator that you see, which is feels like a thick line. And this is the one that then later connects back to the microservices. So I'm going to hand over to Juan Enrique again to talk a little bit about the container platform.
Different services that the team from Santander are using to run this platform. I think that there are several things which are really important, which are the requirements that they have described through their explanations. Speed, agility, cloud native, and this is critical when it comes to make a decision. So the first thing is they need to support this domain-driven architecture based on microservices. So in the end, you need somewhere to run your containers. You know that in AWS, we offer a breadth amount of different services, so you can run containers on different types of platforms. So we have Kubernetes, we have Amazon EKS, we have ECS, we have Amazon ECS. You can run that based on EC2, or you can run that based on Fargate. But when you get all the requirements, mainly the business requirements, that starts to give you some clues where you should go. But at the same time, Santander is a highly regulated customer, as most of you probably know. So they need to meet all the compliance, risk, resiliency, availability. All these things need to be taken into consideration. It's not only about providing the business fastest access to new functionalities and so on. We also need to take that into consideration. So when you look at the need for speed, one thing that always comes to mind is simplicity. We have Kubernetes. It's a great tool. It offers you a lot of functionality, but is there any value for the developers to start to talk about which network or CNI driver I'm going to use? Maybe not. because we don't need that in this specific case. So the initial idea, as John has described, is to give the power to the developers to meet all the business functional requirements. So this way, the developers should just focus on writing code, deploying the code, following all the CI/CD strategy that John has described. So do we need really to run on Kubernetes? And by the way, Santander runs thousands of Kubernetes clusters. Probably not. We don't need any specific thing from Kubernetes. So they made the first decision. The first decision was to use ECS. Why? Because when you use a tool like CDK in this case, or Terraform, that's not the key aspect here, the developer just has to say, okay, I need to deploy this code. I need this amount of resources, this amount of compute resources, this amount of memory, and I'm going to use this role to execute this code because I need that this code talks with this other part of the platform. Okay, can ECS do that? Yes, ECS can do that. Okay, so that is pretty simple, and I can use a tool like CDK to give that capability to my developers without relying in any third party or other teams. Okay, that's fine. But now we have additional decisions to make. Okay, we still want to keep that simple, and we want to meet all these, compliance, availability, resiliency requirements. When we talk about ECS, same thing that when we talk about EKS, you know that you can run ECS or EKS based on EC2 instances, or you can run that on Fargate. As they explained at the beginning, they started 4 years ago, so the landscape of containers in AWS has changed during these 4 years, but now we have a very interesting option, which is Fargate. So if you decide to run your containers based on EC2, it's true that all the complexity of deploying the clusters and so on, all that heavy lifting is on us, and you are, but anyway, you are taking the responsibility of managing where the nodes where your containers are running. So you still, if you choose EC2, you still need to do the sizing, okay? How many traders, in which time zones, how many prices we are going to manage, how many tasks do we need to run, and so you still need to keep doing the sizing. But it's EC2, so if you know, and when we talk about the shared responsibility model and we talk about EC2, you still have a lot of responsibility. You still have to do all the patching. You still have to do all the operating system upgrades, So that again means that you need to have people maintaining your platform. So that's making the things not as simple as they would like. So the next decision that they made is, okay, let's look into Fargate. Can we run Fargate? Maybe, let's look into it. So using Fargate is allowing them to get rid of any heavy lifting on maintaining the platform. So their ideal world where the developer just describes, okay, I need to deploy this code, I need this amount of resources, it's possible. Nobody needs to take care about the sizing of the platform, nobody needs to take care about patching the operating system, done. So that is bringing to Santander, in this case, a lot of flexibility in terms of reducing the BAU, so they don't need people maintaining the platform. Is helping them to deploy faster the new functionalities, but at the same time, it's fully compliant with all the requirements from the regulators, from the internal corporations in terms of risk and compliance. The other thing, which is I think is very interesting, is that ECS, in a very simple way, allows them to be fully integrated with other AWS services. And that brings me to the original name of the session. If you remember, we said a cloud-native platform, because there is a huge difference between running things on the cloud and being cloud-native. So being cloud-native means using the maximum value that the cloud can provide to all of you. So using things like application load balancers, using configuration services like parameter store, all of them fully integrated with the containers platform, it's really valuable for them because they don't need to build integrations with that on-premise tool where they store the secrets, or they don't need to deploy these appliances, which are the usual appliances that runs the load balancing on-premise. They just describe, the developer just describe, okay, this is my code, this is the resource that I need, but by the way, I need also a load balancer, I need also a parameter stored on this platform, and it's fully integrated. So it's making the developers' life much easier than having to be integrated with other tools. The last comment is they are not fully yet serverless, so they are moving to this Fargate strategy. If I'm not wrong, most of the Linux, it's already running on Fargate. That aligns very well with the comment that Jerome did at the beginning, which is cost efficiency. So I don't need this big EC2 instance to run my containers. I just need to define the task, how many tasks, how do they scale, done. So they are finding a lot of cost efficiency using this serverless platform. They are on their way to migrate also the Windows containers to use Fargate. You know, as I said before, the journey or the evolution of the containers platform on AWS has changed a lot during the last 4 years. So containers, ECS, why? Because they are fully compliant with all the risk and compliance requirements, and also because they are simple and they give a lot of power to the developers. Okay, the next topic, and John has mentioned some of these things, is how do we manage the storage? Okay, all of you know that managed services here are very important because in this case, AWS is taking care of the heavy lifting. But I think that it's worth mentioning that managed services are especially useful when it comes to things like Elastic Cache. In this case, Elastic Cache for Redis. Why? You know, running distributed systems which runs in memory, it's really difficult. Maintaining these systems, patching that systems, and so on, it's really difficult, and it's very risky to do that, especially because in the case of this platform, these systems are the systems that are providing this data to the traders in real time. So they are getting this information and making that information available for different services in real time. It's true, as John mentioned before, that, okay, maybe we can afford to lose one price, but we cannot afford to lose all the platforms. So leveraging services or managed services from AWS like Amazon Elastic Cache, I think is really valuable for them. And by the way, now we are launching the serverless version, so we will talk about that probably in a few weeks. Okay, the other services that they use, I'm not going to spend too much time here, but the other services that they use for the storage are DynamoDB, you know, non-SQL database, highly efficient, but I think that it's very well aligned with their strategy to be present across the world. So they, as John explained, they are present in different markets in the world. So DynamoDB provides them with high-speed persistent storage for their data, but also will allow them to, you know, deploy across the world. Finally, OpenSearch, I will talk about OpenSearch later, and S3 will take care of all the static contents. The other part that I think it's really important is how Santander has managed to provide to all the applications with some specific capabilities that are important for a regulated entity. And I'm going to spend a bit of time in two different aspects. The first one is the connectivity or the networking, and the second one is security. You know, usually when it comes to talk about connectivity or security, we spend a lot of time with the different financial services customers. So the Santander group started to build their own their landing zone a few years ago, and one of the things that they are providing is this connectivity to the different applications. So how the connectivity in Santander works. They have different zones divided on the connectivity. So they have their on-premise systems, they have their AWS systems, and they have the internet and also the third parties. And as you have seen before, we have traders, we have on-premise systems on their private cloud. We have third parties like Transfig or Bloomberg also feeding data to the platform. So imagine if when you start this project, you have to spend months or even years building all this connectivity. This connectivity is available out of the box in the Santander landing zone. It relies on Transit Gateway. Transit Gateway is the central piece which takes all the decisions about how the traffic flows between all the systems involved on an application. Of course, they are using Direct Connect to connect with the on-premise system. So all the traffic that flows between the on-premise systems and anything that runs on AWS is fully encrypted. When they started to build the platform 4 years ago, we didn't have at that time MACsec supported on AWS, so they use the typical architectural pattern based on a transit VPC, where they get all the traffic that gets out of AWS or gets into AWS, and it's fully encrypted. In this case, they are using Cisco appliance to do that encryption. They are now in a project to migrate that to use MACsec and get rid of that appliances. But that way, they are guaranteeing that all the traffic that goes to their on-premise systems, it doesn't matter if they are the traders platform or it's their private cloud, it's fully encrypted and fully managed by the team. The second thing is that once the traffic arrives to or reaches AWS, this is managed the transit gateway. Why this is important? This is important because there are some specific rules which are mandatory. By the way, I didn't mention this before. They have some teams which are global. For example, networking and security are global functions into the bank, so you need to be fully aligned with that teams and the policy that teams dictates. So when the traffic arrives to AWS or the traffic wants to get out of their AWS accounts or platforms, it needs to be inspected. Okay, so if you go to the internet or something comes from the internet to you, it needs to go through the North Firewall. That goes through the transit gateway. So all the traffic from the internet comes into the VPC, the ingestion, let me say the ingestion VPC, goes to the transit gateway. The transit gateway sends that traffic to the North Firewall. If your application wants to speak with a third party, like Bloomberg, for example, that traffic that gets out of the VPC goes again to the transit gateway. The transit gateway sends that traffic to the North Firewall. The third parties goes also through the North Firewall. And the traffic gets inspected, approved, or dropped, and then done. So transit gateway in this case is providing to them this kind of flexibility. Also for the traffic, when they need to speak east-west, for example, if they need to speak in the future with other regions or in AWS because they are deploying additional capabilities over that regions, it will be, let me say, easy. Just all the traffic will go to this transit gateway and then they will make the decisions about the traffic in this transit gateway. So this is something that I have available out of the box on AWS. This is run by a global team, but it's not impacting them in any way. They just plug in the application and everything, let me say, works like magic, no? And on that case. And finally, John also mentioned that they are using private link to connect to these third parties. They also, in some cases, not specifically in this, uses private link to connect to other applications inside the bank. So one of the things that they are providing also to the different projects in the bank is that they have an account, which is the shared services account, where they can plug in these private links and get access to that services or data or whatever they are publishing in that private links. And again, as when you get out of your VPC, you always go to this transit gateway, your traffic gets inspected. So I think it's a pretty smart architecture what they have implemented today. So let me go to the next part, which I think it's even more important because, you know, in the end, they are a financial services company and they need to be sure that everything is in place and that they don't make any kind of mistake. So I'm going to start about the a very classical problem that we find when we talk with financial services customers, which is how do I give the right autonomy to the developers to define roles? Okay, so imagine you have your development team. They have built this microservice, and this microservice needs to talk with the DynamoDB table. In the usual world, usually, and probably most of you know this and have suffered this, you have to go to your ITSM tool, open your ticket, describe, okay, I want to talk from this microservice to this table on DynamoDB, I want to run these permissions, and I want that this role is being assumed by this pod or task or whatever you are using that role. So someone will read that ticket, and maybe 2 hours later, or 2 days later, or 2 weeks later, will answer to you, giving you the role. That doesn't make the things very easy. So this approach that the Santander has put in place gives a lot of autonomy, well, not a lot, the right autonomy to the projects to create, for example, their roles. So if a developer wants to create a role where they define this policy, no, I need that my microservice, speaks with this DynamoDB table, they can do that. Okay, but that's a risk. He could elevate his privileges to do something not very interesting. So what they have done is that they have using service control policies inside their organization. They are limiting the access to, let me say, risky operations. For example, the projects cannot execute any action that will modify anything related to the network. So that's done only by these global guys who runs the network. But also, when they give this autonomy to the projects to create these roles, what they are forcing to the project is, if you create a role, you need to attach a boundary. So they have defined a boundary which restricts the power of the role. So it doesn't matter what you put in the role. You can give full permissions in the role. But as you have to put this boundary attached to the role, your role is going to be limited. It doesn't matter what you put over there. So that way, the security people in Santander feels pretty comfortable because they know that nobody can get out of the boundaries in this case. But they are getting a huge value from that because they are giving a lot of autonomy to the projects to not rely on a third party who needs to approve, to build, and that role, and so on. And that's very important. I have already talked about the networking and the firewall, so I'm not going to insist in that. I think that the two other important things is that when they started to build the trading application, at that moment, the identity was a challenge, so they decided to use Cognito, fully managed service. It works, or it allows you to define your identity practice, the authentication, the authorization mechanism, fully integrated with your application. So very easy. Now they are in the path because now the landing zone is providing these identity services, in this case based on Microsoft Entra ID, and now Azure ID, or formerly Azure AD. So they are in the path to migrate to that identity strategy. And the other important thing is encryption. Again, this is something that is defined by the global security team, and they are enforcing all these policies. So all the traffic in transit, encrypted. All the traffic at rest, encrypted. And there is a policy. If you want to deploy an EBS volume or you want to deploy an S3 bucket which is not encrypted, it's not possible. It's not allowed. We have this service control policy, and it's not allowed. You cannot do that. Again, it's all about simplicity and providing them with this speed through autonomy. Okay, so I think it's pretty interesting. Same thing happened with the certificates. It's something that usually we don't look too much at it, but it's very important. Probably a lot of people in the room has gone through this situation where someone forgot to renew a certificate, or they renew the certificate, but they forgot to update the certificate on the load balancer. So I think that that's a very tiny and very simple thing, but using a certificate manager for AWS, it's allowing the Santander team to forget about the management of these certificates. So it comes to the original statement, no? Keeping the things simple, keeping the things really fast. And just to close, monitoring, they are using two main pieces to monitor the platform. CloudWatch, I think, is pretty important because, having available on real-time KPIs regarding, for example, the performance of a piece like Redis, I think is critical for them. The prices are really important. The speed matters in this case. But not only that. For example, other interesting piece is having an end-to-end vision of what's going on the platform to be really quick on detecting any kind of problem is important. So using pieces that are provided by CloudWatch, like CloudWatch Containers Insights or using X-Ray, it's really interesting, where you can see the end-to-end of the platform that you are running. And then they are also leveraging OpenSearch. OpenSearch is ingesting all the application logs. They are using Kibana to build these dashboards, and they are not using only the Kibana dashboards for technical KPIs. Also, some business KPIs are built and included in these dashboards. And finally, John already mentioned this part. All the ingestion from these third parties, from Transfig and Refinitiv and Bloomberg, are done through this private link. As I explained before, they have, these shared VPC services where they can plug in these third parties. Today they are using these 3 ones. Maybe in the future they will need to use additional ones. But this way, they are able to guarantee that all the traffic is managed and is inspected and goes through the right paths inside the platform. So now, to just close the session, I'm handing over to Jerome.
Thank you, Juan. So before we leave a little bit of time for Q&A, if I step back a bit and look at that journey, 4 years ago, when we started in Santander, basically, at least Santander CIB, were mostly a vendor shop. So to start such an initiative, which is checking many of the boxes of transformation, whether it's cloud native, CI/CD, agility, microservices, especially in the context of electronic trading or pre-trade activity in market, let's say that many people did not necessarily believe that they could make it. Okay, and 4 years later, we did deliver on our promise, which is basically focusing on added value business features, making them more reliable and delivering them much faster. Okay, and so at the end, we added value for the business, and ultimately, this is what we wanted. Also, worth mentioning that at least in Europe, 4 years ago, maybe it's changed a little bit since, maybe in the US, maybe a bit different, but I don't believe there's that many capital market activity that have implemented a cloud-native application in the pre-trade space. I don't think there are too many. So for that reason, I mean, we are pretty proud of what we've done. Now, as you've seen, it's pretty complex. The journey is not over because we have more asset class to implement, more geographies to roll out. Okay, so the journey actually is never going to be over. It's not a project. It's like we say, it's more a product. So there's many more things to come. So here you have a list of things that have already been mentioned by Juan and John. So I will not go over them necessarily. I'm just going to probably point out a couple of them. I think Santander initially, it was really about having an efficient trading platform to compete with our main competitors. And the strategy evolved a little bit, and we have a strong globalization agenda. So the cloud, obviously, is a strong enabler in that globalization agenda that the business have. Now, it's worth mentioning as well that, and I think Juan mentioned it a little bit, security regulation are specific in some countries. And therefore, even though using the cloud should be a push button from a technical standpoint, the implementation is always a bit more complex. And that's something we are actually facing as we speak. Also, the landing zone that Juan mentioned, when we started the project, we were probably a little bit ahead of the curve vis-à-vis the group landing zone. So the question of the maturity of the landing zone vis-à-vis the project delivery has been let's say a struggle at one point for us, and that's why it's very important to include very early in the start of the project all the CISO teams, the CTO team to address this as proactively as possible. And then I will finish with the last thing, which is probably about the talent, the search for talent. To have a very strong cloud engineer, actually over the last 4 years proved to be a difficult task, at least in Europe, in between Spain and the UK, where most of our forces are. And this continues to be a point of attention for us to search for talent. So just to conclude, and before we open let's say the room for Q&A, this is just the beginning of a journey, even it has started 4 years ago, opening the door for many more assets in capital market, but we proved again in Santander that transforming with AWS was actually a success for us, so leaving the door for many more success. Thank you.